So the greenhouse effect is basically a naturally occurring, I can't figure out the word to use there, process that keeps Earth at a certain temperature that we can live on, okay? What first happens is sun's rays come down. What do they come down as? No, UV rays. So ultraviolet radiation gets emitted from the sun and comes straight down to Earth, okay? It hits Earth and it usually bounces off as good infrared rays, which are heat rays, okay? These infrared rays should be re-radiated back into the atmosphere and eventually out of Earth and into space, but something is causing them to come back down, which you're seeing here. What is this something?
Water.
Water vapor. What else? So the infrared rays is supposed to go back up to Earth, into the atmosphere, out of Earth, but something here causes them to bounce back. What are we calling this something here? Wow. I'll pause. Thank you, Taylor. Greenhouse gases, in this case, I'm showing you a cloud because it's water, cause the infrared rays to come back down to Earth, warming Earth. This is something you have to represent in your diagram in a form of an animation. Okay, take a picture of it. Yesterday, I had a slide where we had to write what were the most heat-trapping gases. I made a slide here that kind of references abundance and potential. So the most abundant greenhouse gas is water because water vapor is highly concentrated in the atmosphere. Why we don't consider it the number one greenhouse gas of concern is because water is a non-persistent gas. It goes away from our atmosphere in 10 days. The maximum water vapor will last in the atmosphere is 10 days. Plus it reacts with a lot of things. CO2, on the other hand, is very persistent and is abundant. So this is our number one greenhouse gas of concern, right? But we also need to know heat trapping potential. So yesterday, I think it was Devin maybe, asked me what is GWP. Was it you or somebody? So it's global warming potential. And this is the order of the gases in global warming potential. Now notice I added one. So I found this on many websites. So apparently sulfur hexafluoride is now a greenhouse gas that I didn't know of before. And it is a massive heat trapper. So it's number 2 on the list of heat trapping. What is H2O? Water. What's CFC?
Chlorofluorine.
Chlorofluorocarbons. HCFC? Hydrochlorofluorocarbons. Nitrous oxide. What's CH4? Methane. And then CO2? Carbon dioxide. So CO2 is the least heat trapper, but since it's so abundant and it's so persistent, it's going to trap heat over long periods of time. So we've been talking about what causes global warming. Now we're going to talk about the effects of global warming. These are the major problems that are linked to the warming of Earth. What are they?
Melting.
Melting of ice caps. And if we have excess melting of ice caps, what's the result after that? Floods. What else? Or why? Why do we have floods? Good. Sea levels rising. We have floods for 2 reasons. Sea levels rising, and we also have floods because we have what is considered extreme weather conditions due to our climate changing or the warming of Earth. What is weather? If I look at the Weather Channel, what am I looking for?
Temperature.
Temperature and
Climate over.
And precipitation. Climate is weather over a long period of time. So the extreme weather is going to lead to periods of excessive rain, periods of drought, no rain. We also are going to have periods of high temperatures or heat waves and periods of low temperatures or extreme colds. And if you look at records, and I'm not going to show them to you. You could go ahead and look at them. Over the past couple of years, 10, 15 years, record highs and record lows have been documented across the world. So extreme weather changes across the world. All right, so I wanted to just kind of touch a little bit more on the changes in the patterns of rain and temperature. We know that temperature and precipitation over a long period of time are climate, okay? And climate determines what? No, weather is daily temperature and precipitation. Climate is that over time. Climate determines what?
The biome.
Good. If we're going to have these massive changes, we're going to have shift in biomes. If we have shift in biomes, what's going to happen? Let's go in order. What is directly affected by temperature and precipitation in a biome?
The plant.
Plants, before plants.
Yeah.
So we're going to say species, but before that is what? Think of your presentations. What did you have to talk about? Definitely habitat, because if you're in a polar region, your habitat is going to be destroyed. What was before species? What did you have to cover that was important for species survival and the biome's survival? Yes, soil. Good. And then if you have loss of species, you're going to have shift in diversity or threats of diversity to that biome. So here's a graph, or a, what do we call this? A diagram of shifts in biomes in the last couple of years. Here, and again, a lot of these slides are just going to be information, just to give you some idea of what's going on in the world. In 2015 was the warmest year since we started recording temperatures in the 1800s across the world, okay? Somebody asked me what happened in 2016. We still had record highs, but we can say the warmest year in the world, right? We have record lows too, and I didn't put any of those graphs, but look them up. They're across the board as well. Here's a picture of melting of ice cap or glaciers in Alaska. And yes, it's the same time of the year, okay? But the difference from 1948 to 2004 in terms of what ice was available. And here's like a different picture of you seeing the mass amount of loss of ice. Sea level rise, a big thing to be worried about, especially if you live near oceans, right? This is a map of areas that have experienced specific sea level rise, and it's the entire East Coast. Then you've got this area, and again, around here, and this will tell you the amount. Here's a scary slide for you. This is Florida. I focused on that. Our sea levels have risen in the last 50 years approximately, less than a meter, right? But if we get to the meter, look at the areas that we're in trouble, okay? This is where we get our water from, by the way. Yeah. And then if 2 meters, right? So think about that. And then this is the slide we skipped. There was nothing to uncover, but I just want you to know that there is a consensus across the world. So this panel is across the world, and they all agree that Earth is warming, that Arctic rise is warming more than anything else. The Arctic temperatures are rising more than any other area on Earth. There's glaciers melting, there's flooding, there's prolonged droughts, and sea level rise across, it's a consensus across the world. This is what they're really worried about, what is called the tipping point. And a tipping point is basically the point of no return. So once you get to this place where you see a problem that they're worried they can't fix, because we're at that point. And these are some concerns that we feel we've reached a tipping point. What are they? Droughts in specific areas. What else? Floods, especially in low-lying cities, right? Are you not seeing this all over the news? What else? What? Fires. Seeing that on the news, right? What else? Yep. I'm not really seeing that on the news, but what else? Good. Storms or weathers. Extreme weathers, like we talked about before. Yep. That's definitely a tipping point. How do you get it back? And then ecosystem collapse. So why do ecosystems collapse? If biomes shift, ecosystems are within the biome, and they shift as well. Polar bear, and it broke my heart. So there's definitely going to be questions that are linked to what areas are most susceptible to damage because of global warming. This one's pretty obvious. The Arctic, the polar regions, all of those areas, the melting is going to occur. If temperatures are rising, cold areas are going to be affected right away, right? But really what you have to remember when we learned about this is that those areas, because of their climate, have very little chance for regeneration. So once the biome shifts, the chance of recovery is limited because they have a low tolerance for change. The species and the plants and everything, okay? And as you see there, they're actually changing color somewhat. They're getting darker, which is, interesting enough how evolutionary patterns are showing. Another major threat to global warming is coral reefs, and I'm going to talk more about that tomorrow. What do we know about coral reefs? Most diverse. Look at diverse, diverse, diverse. Our most diverse biomes are the most affected because forests have the most species diversity, rainforests, wetlands are up there on diversity. So these three biomes are most susceptible. And then you got to also think about the fact that you have increases of some organisms that we really don't want to see, like insects and bacteria or pathogens, because warm temperatures is what they thrive in, okay?